Okay, so we're starting Unit 6, and Unit 6 builds on Unit 5. So I had somebody ask me last class period, do you think I should retake the exam, or do you think I should do corrections? And that's an interesting answer, because we go through Chapter 5 so that we have what we need to do this unit and the next unit. So sampling distributions is our foundation for confidence intervals and hypothesis testing. Sampling distributions are not something that you typically see in the free response on your AP exam. Sometimes you might, but instead, usually they ask you for a confidence interval or to test a hypothesis. So if you're feeling okay about the last unit, then I would say just do corrections. But if you're like really striving for a 5, then I would do the retake and see where you're at. But ultimately, we learned Unit 5 so that we could do the things that we needed to do in Unit 6, which is confidence intervals, and Unit 7, which will be hypothesis testing. So these 3 paragraphs are from the intro in your textbook to this unit. And you'll notice that the first 2, as we go through them, are basically describing what we did in Unit 5 that you just tested on. So it starts with, how long does a new model of laptop battery last? Or what proportion of college undergraduates have engaged in binge drinking? And how much does the weight of a quarter-pound hamburger at a fast food restaurant vary after cooking? These are the types of questions we would like to be able to answer. So the first 2 I do think are pretty interesting. How long does a new model of laptop battery last? I do think in this day and age it is something that people want to know, how long the battery for their technology will last. Like, I used to have a Apple Watch and now I have a Fitbit, and the biggest reason is because I had to charge my Apple Watch every day, but my Fitbit I only have to charge like every 5 days. So maybe as you get older, your battery lifetime matters a little bit more, but I do think that that's something that would be interesting to know. What proportion of college undergraduates have engaged in binge drinking? I personally think that would be interesting to know. The quarter-pound hamburger, I don't know why. I don't know why you would want to know that, but maybe some people do. If we wanted to answer these questions, though, it wouldn't be practical to look at the lifetime of every laptop battery. So that's this blank in the next paragraph. We want to know these things about laptops or undergraduates or hamburgers, but it's not practical to look at every laptop battery or ask all college undergraduates about their drinking habits, or even to weigh every hamburger after cooking. That's just, it's not practical. Typically, it's too costly and takes too much time. So instead, we take a sample. So we take a sample of individuals. So in that case, it's batteries or college students or burgers. And we use this sample to represent the population. So instead of looking at thousands and thousands of laptop batteries, instead we are going to take 100 laptops and let those represent the entire population. Our goal in each case is to use a statistic And then it reminds you, like p hat or x bar, to estimate an unknown population parameter. So what this is getting at is we are going to use our 100 laptops to estimate the lifetime of the battery for all of the laptops. We can do this. We can take a sample and then use that to estimate the entire population if we randomly select our sample. If we randomly select, we should be able to generalize our results to the population of interest. So the last unit we're going to do before we start reviewing for your test has to do with this last sentence in this paragraph. So this is really the only time we discuss it in this unit, but I think it's worth underlining because coming up pretty soon, it becomes a really important idea in stats. That the reason that we can say this sample estimates or represents our population is because we chose it randomly. If we don't choose randomly, then problems can arise with using it as an estimate. So this is basically going through what we spent the entire last unit on. We want to know things about a population. We take a sample because it's not practical to look at the entire population, and then we use our sample as an estimate for that population. So this is where, this last paragraph is where we start to talk about some new things. So we cannot be certain, I'm just looking for a new color marker. We cannot be certain that our conclusions are correct, because a different sample would probably yield a different estimate. So you were tested on this idea in the last unit, and it's sampling variability. So if we looked at 50 college undergraduates and calculated the percent of them that binge drink, we would probably get a different percent if we did another 50 college undergraduates and calculated the percent of them that binge drink. And our first one, it might be 42%, but then in the next one, it might be 44%. And that's normal and okay. Because of that, we can't be certain that our estimate is the true population estimate. So instead, we use the language of probability. We use the language of probability to express the strength of our conclusions. So when we say strength, we're specifically referring to how confident we are in our estimate. So next to that word strength, I'm writing in confidence level. Our strength of our conclusion is how confident in our estimate we are. This allows us to take chance variation into account when we're estimating. So chance variation is a different way of saying sampling variability. We can use a confidence interval or a confidence level to help us account for the fact that we know that different samples will have different values. Here, I want to add in the most common confidence levels. So when we say confidence level, how we normally describe that is like 90%. We're 90% confident, or we're 95% confident, or 99% confident. Those are the most common confidence levels. So we would get our estimate, and then we would be able to say we're 90% confident that the true value is, and then you would give your confidence interval. So in order to calculate a confidence interval, to start looking at expressing the strength of our estimate, we need a couple of new vocabulary words. So the first one is point estimate or point estimator. So this is the statistic that provides an estimate of your population parameter. The value of that statistic from a sample is called a point estimate. So really what they're saying here is that the statistic you calculate from your sample is the point estimate. This is all just fancy words for things you already know. The most common point estimates are p hat and x bar. The most common point estimates that we have looked at together so far are p hat and x bar. Now, on our chapter overview, I mentioned some other ones that I thought might be interesting to know in addition to these two. So our statistic could also be a range, or a maximum value, or a median value. It's not always just the average of the sample or the percent of the sample. So keep in mind that these are the two most common, but we could also be interested in range, or maximum, or median. So you would look at your sample, and if it asked you, find the median, that would be your point estimate. Then we can use this point estimate to build our confidence interval, and that's the last box. It says a C% confidence interval. Well, what they mean by that is a 90% confidence interval, or a 95% confidence interval gives an interval, so a range of numbers of plausible values for the parameter. So that first blank is the word plausible. So it's going to give us a range of numbers. The interval is calculated from the data we collect, and it has the form, your point estimate, plus and minus. So this is a plus and a minus. This new thing called your margin of error. So all confidence intervals are found by taking the statistic you calculate from your sample and adding and subtracting your margin of error. So your margin of error is by how much we could be off by, how far from the true value we might go. So I just want to write down here that when we're talking about a confidence interval, will have a lower bound, comma, and an upper bound. So it's a range of values that the parameter can be. You get your lower bound by subtracting the margin of error, and you get your upper bound by adding your margin of error. So you take your statistic, subtract, that's your lower bound, add, that's your upper bound. So this is a whole lot of information at once, but as soon as we do one example, I think that it all starts to come together. So our first example is on the next page. The first thing that we're going to look at is confidence intervals for a mean. So remember, I was telling you that our two most common statistics are mean and proportion. So the first part of our lesson is focusing on the mean of a sample or the average of a sample. The problem that we're going to build a confidence interval for is looking at the amount of sugar in soft drinks. So there is concern about how much sugar is in soft drinks. To test sugar content, a researcher randomly sampled 8 soft drinks from a particular manufacturer and measured the sugar content in grams. This is the content that he got for each one. We want to use the data to construct and interpret a 95% confidence interval. So I'm going to highlight 95%. And they want that interval to describe the mean amount of sugar in this manufacturer's soft drinks. So essentially, they want us to find a range of values that the true sugar content could be. When we go through and do these problems in this lesson, we're going to do these 3 steps always. We're going to look at what are we doing? What are we really looking for here? How do we do it? And then make a conclusion based off of our calculations. So in this lesson, it's a 3-step process. What are we doing? How do we do it? What is our conclusion? So let's start at the what are we doing? We want to estimate. The population's mean, which is denoted with mu. That's just a reminder, this is mu. And then I highlighted this last part of the prompt because that's what we write down in the blank. We copy it down word for word. So we want to estimate the population's mean, and then I'm just copying it straight from above. Amount of sugar in this manufacturer's soft drinks. Then I'm going to wait just a second because I know that I write faster than you guys. So we're trying to estimate the true sugar content, average sugar content in all of their drinks. We want to do this with 95% confidence. So by the time we're done, we want to be 95% confident that the true value is in our interval. Okay, how do we do it? Well, this is related to our first page. It's this guy. So it's our point estimate, and in this case, that's our sample average plus our margin of error. And our margin of error is this multiply problem. It's this thing called a critical value multiplied by the standard error of our sample. So let's start with what we know how to do. Let's find our point estimate. So remember, our point estimate is the average sugar content in our sample, because that's what we're trying to estimate, the average sugar content for the population. Let's use our calculator to do that. We could just add them up and divide by 8, but we need other information, so let's add it in to our list. So go to Stat, and then Calc. If you need to clear out a list, remember you highlight the list name and hit Clear, Enter. Then you're going to enter in those 8 values. Give you about roughly 15 more seconds. 10. Okay, so then we go to Stat again, arrow over to Calc, and we want to run one variable stat. So we're looking at one variable, and that's sugar content. To change your list, you hit blue button and the number of your list, enter through, and I get a mean of 22.5. So the average of these 8 soft drinks is 22.5 grams. That's not too bad. Okay, underneath it wants us to identify our sample size. That was 8. And the reason why it wants us to identify our sample size is so that we can find the standard error. So standard error is a different way of describing standard deviation. It tells you how spread out is your sample. How spread out is your sample. So how spread out are these 8 values? So to find that, you take this new value called S sub x. So S and a little x, and you divide that by the root of your sample size. So this formula is new. And then this is why I had us enter in our sample into our calculator, because now our calculator gives us S sub x. So our standard deviation is 7.191. 7.191. So we got that from our calculator. If you think you might be confused on that later on, maybe write yourself a note. Then we're going to divide that by the root of 8. And that's going to give us our standard error. So if we plug that in, I believe we get 2.542. Then the last thing we need is this thing called a critical value, and it gives you this little note that we get it from the table above. So before I go much further, I just want to note that next time's lesson, I go through and really explain to you what these two elements are. What exactly is your critical value, and what exactly is this standard error that we're seeing here? So for today, we're just going to fill in the numbers and find our intervals, and then next time you'll have a better understanding of where critical value comes from, where standard error comes from. So the critical values can be found on your pink table at the very bottom. So if you go to the very bottom of this pink table, you'll see that it says confidence level C. And then above it, you see the confidence levels. So 90%, 95%, 96%. If you go one more row up, that is your critical value. It's similar to a Z-score. So if you want to be 95% confident, you use the critical value 1.960. 96% confidence is 2.054. It's always this number. These never change. So for 96%, it's always 2.054. And what you have here is the same thing. The numbers are the same. I just put it for you on this worksheet because typically I don't give this table out yet. So confidence level has a matching Z-score that we have to use, and that's our critical value. So in this case, for 95% confidence, we're going to use 1.960. 1.960. And I'm getting that from this table. Going to 95% confidence and using the critical value above it. And now, finally, we have everything that we need to construct our confidence interval. So I usually draw a line here just to separate my numbers from my calculations. You don't have to do that, but it helps me keep my work neat. And then I'm going to set up my interval exactly as it looks right here. So I'm going to start with my X bar. Our sample average was 22.5. Then plus or minus our critical value, 1.960, multiplied by our standard error, 2.542. So I am getting this from this formula. I'm copying those numbers down in the same order. Then I usually draw two little arrows coming out. I always find my lower bound first, and then I find my upper bound. These symbols are just reminding me what I do to find those. So for lower bound, I subtract. For upper bound, I add. So I plug into my calculator, 22.5, subtract 1.960, multiplied by 2.542. Then I'm going to round that to 2 decimal places, so 17.52. Then I usually just go up and copy that subtraction. So you just highlight it and hit enter. And then I just arrow over and change the subtract to a plus. You can just type it all out again too if you want. So this one I'm going to round to 27.48. And what I now know is that I'm 95% confident that the true value is anywhere between these two numbers. So our sample value is right in the middle, and the lowest that the true value could be is 17.5, and the biggest that the true value can be is 27.5. So we're 95% confident it's somewhere in this interval. So we say down here in our conclusion, we are 95% confident that the population's mean, and then we write that same sentence again that we highlighted in the prompt. So we are 95% confident that the population's mean amount of sugar in this manufacturer's soft drinks. And I'll wait a second because I write fast. We're 95% confident that the true mean amount of sugar in this manufacturer's soft drinks is anywhere between 17.52 and 27.48 grams. So the true mean is somewhere in that interval. You're hanging in? Okay. Let's do like 10 seconds and then we'll try the problem on the next page. We'll go through it together step by step. So 603. Before I read the prompt, I'm just going to highlight that we are following those 3 steps. We're going to make sure it's clear what we're doing, how we're doing it, and then make our conclusion. So to estimate mu, the mean salary of full professors at American colleges and universities, you obtain a random sample of 400 full professors. Okay, so that's my N. I'm either going to circle that or highlight it. Now we get lucky in this problem because they just tell us the sample mean is 73,000 and the sample standard deviation is 4,400. So I'm going to highlight those. They want a 96% confidence interval for the mean salary of full professors at American colleges and universities. So when I fill out the what portion of my response, I am going to follow this like word for word. The only thing that I don't write usually is this mu. So I'm going to help start you. We want to start by saying we want to estimate the population's mean and then we write down this last part of the prompt that we highlight. The population's mean salary of full professors at American colleges and universities with, we want to estimate the true population mean of salary or mean salary of full professors with 96% confidence. So we always start with, we want to estimate the population's mean, add in your context, and end with your confidence level. So there's 3 parts to this, and if you think it would help you, I would mark out those separate parts. So for instance, for all of these problems, you start with, we want to estimate the population's mean. Then the next sentence comes exactly from your prompt. So, salary of full professors at American colleges and universities, that comes from what I have highlighted. And then you end with your confidence level. So each one of these has 3 parts, and you just want to make sure that you include all 3 parts. Okay, down the side, I'm going to remind you of what values you're looking for, and I'm taking them straight from here. So the first thing that you need is your X bar. That's your point estimate. Your N, your standard error of your sample, and then your critical value. Once you find all those, calculate your confidence interval. So I'm going to leave mine up so that you can refer to it if you'd like without having to flip back and forth. So you are trying the how without me. So I'm going to freeze mine from the last problem on the screen so that you don't have to flip back and forth if you don't want to. And then I'm going to I'll fill out mine and come check on you, and then we'll check in together. For all of these, I rounded, I think, how did I round? Let me tell you. To the, when I needed to calculate, I rounded to the nearest whole. So don't do the conclude yet. Just find your lower bound and your upper bound. Okay, for my lower bound, I got 72,768. And then for my upper bound, I got 73,672. Did you guys get the same thing? Okay. So now to make your conclusion, I'm going to break up this statement like I did here, so that I can help you include all the elements. So when you write your conclude, you always start with we are, and then make sure that you include your confidence level. So that is your first part always. That's part 1. And then the last part is anywhere between. Just deciding on a color. I'm running out of highlighter colors, family. Okay, so you guys try to do your conclude without me. And you're following the 3 parts of your conclusion. We are 96% confident that the population's mean. Copy down that same sentence you've been using, and then end with your confidence interval. I'll leave this frozen on my screen. Okay, I'll unfreeze in just a second. Okay, so we are 96% confident that the population's mean salary of full professors at American colleges and universities is anywhere between $72,768 and $73,672. If you didn't put your dollar signs on, do that now. So at this point, before we move on to proportions, I want you to go to our module in Canvas and do the first quiz. It's just 2 quick questions. You don't have to do any interpreting. It's just finding the critical values and then finding 1 confidence interval. So do the part 1 quiz questions.